Review Unit 3, Systems. This is not something I normally do, but given the circumstances, I'm going to complete this entire review for your reference as you prepare for the Unit 3 exam. Let's go to work. Now it says no calculator is necessary. Please do not use a calculator. And that's only on these first couple questions. After that, we're going to allow you to use a calculator. Okay, so 1 and 2 is very, very simple. Estimate the solution of the system. You've already graphed them. So right there is the solution. And give your answer in the form of a point. That looks like the point 0, 2. That's the estimation. Now, I could plug it in and make sure that it works, but what you'll see is that it works in both of those. The next one. Now, that point we can see is not, most definitely, not a nice even round point. Okay, so I'm going to say it's approximately 3.75 and approximately, I don't know, we'll say 2.25. Hope that's close enough. If you're within a half there, I would be very lenient with that. Just trying to get a close approximation. Again, number 2 is why we say that graphing is the least accurate form or method to solving systems of equations. Numbers 3 and 4 says estimate the solution by graphing each equation on the graph provided. Give your answer in the form of a point. Number 3, my y-intercept is -7. My slope is 3, so 1, 2, 3 over 1, up 3 over 1, 1, 2, 3 over 1. So somewhere like that. And my y-intercept is 3. And I down 1 over 3. There it is. That's my point. So my point of intersection is approximately 3, 2. Looking at number 4, my y-intercept again is 7. My slope is 2, so up 2 and over 1. I could have went down 2 and left 1, down 2, left 1, down 2, left 1. Get that line there. And y equals 3 is a horizontal line through 3. So my point of intersection is right there, which is the ordered pair, -2, 3. -2, 3. As you can see, this goes rather quickly. Again, estimate the solution to the set. If we look at 5 and 6, both of those, neither one is in standard. They're both in standard form, excuse me. So the first thing I would need to do is solve them for y. So I'm going to add 2x to both sides. So 2y equals 2x plus 4 divided by 2. Y equals x plus 2. There's my first one. Up 1 over 1. And then the second one, I just subtract x from both sides. I go to a different color just for fun. So I have y equals a -x. X minus 8, so -8. Negative x is down 1, left 1, or up 1 over 1. There it is. The point of intersection is -5, -3. I'd be doing the same thing for number 6. Start by subtracting x from both sides. So 1/3 y equals -x plus 2. Multiply by 3. Multiply by 3. So y equals -3x plus 6. So there's 6 down 3. 1, 2, 3 over 1. 1, 2, 3 over 1. Oops. Boy, I totally missed that one. Sorry about that. Something like that. And then add x to both sides. Let me go to blue here. So y equals x minus 10. So up 1 over 1, up 1 over 1. Now I want to go back and just make sure I did a little bit better. So here, 1, 2, 3 over 1. 1, 2, 3. Yep, there's the point. So that is 4, -6. Now, if I really wanted to, I could plug both those into Desmos and just double check, but those are right off. The next set, it says solve the systems using any method. Any method I so choose. I'm going to do a couple of these, and then I'm going to show you something genius and go from there. Number 9 is set up for substitution. I can substitute that y, or that 5 in for that y right there. So x plus 5 equals 4. Subtract 5 from both sides. X equals a -1. So my solution is -1, 5. That was set up beautifully for substitution. Let's see if there's another one that's this one, number 12. That's set up beautifully for substitution. Let's do it as well. Put that in for that y. So 6x minus 2 times 3x minus 5 equals 10. I can distribute then. 6x minus 6x plus 10 equals 10. 6x minus 6x cancels, so I end up with 10 equals 10. Did I do something wrong? No, and this is true, so that's infinitely many solutions. That can absolutely happen. Okay. I'm going to do one more. I'm going to do number 10. Now, it's pretty close to the elimination method, but I'm going to cancel out my x's. Just rewrite this first one, 6x plus 2y equals 8. And then here, I need to multiply this one by a -2. That would get me a -6x. So -6x minus 2y equals -8. Uh-oh, watch what happens. Cancels, cancels, cancels. 0 equals 0. Yeah, so that's infinitely many solutions. Oh, that's funny. You get 2 of those on the review. Guess I better do one more just for fun. Let's do this one. We'll multiply this by a -2. See what happens. So -2x minus 2y equals -2. Now use the addition method. Cancels, cancels. So 0 equals 2. Well, that's not true. So it's no solution. Now, this thing said I could use any method. So I'm going to use that. I'm going to do any method for number 7 and number 8. So let's look at number 7 here. 7 is 3x plus 3y equals 9. And x plus y equals 3. Look, it's the same line. Therefore, that's going to be infinitely many solutions. Let's do this last one here. Let's go x minus 2y equals 8. And -1/4 x plus 2y equals -11. I'm looking for that point of intersection, and there it is. -4, -6. And let's finish out this last page. Oops, we got 2 pages left. Sorry. Back to work. Write and solve equations with the following solutions. Carrie sells glasses of Kool-Aid for $1 each and lemonade shake-ups for $3 each. One day she sold 10 more lemon shake-ups than glasses of Kool-Aid. She made a total of $190. Okay, so we're going to call them K for Kool-Aid, L for lemon shake-ups. So one day she sold 10 more lemon than Kool-Aid. So K plus 10 equaled our lemonade. And then we know the price was 1K plus 3 lemonades, and that got us $190. Cool. Now let's use substitution. Let's substitute that in there. So I now have K plus 3 times K plus 10 equals 190. So K plus 3K plus 30 equals 190. So 4K plus 30 equals 190. Subtract 30 from both sides. 4K equals 160. Divide by 4. K equals 40. So plug that in here to be L equals 40 plus 10. And L equals 50. So I had 50 lemonade and 40 Kool-Aids. Cool. Number 14. The perimeter of a rectangle is 14. Length, width, length, width. Well, if the perimeter is 14, half of that would be 7. So I got L plus W equals 7. And then the length of the rectangle is 4 more than twice the width. Well, the length is 4 more than twice the width. Now, I can do this any number of ways. I'm going to choose substitution. I'm going to substitute all of that in for that L. So 2W plus 4 plus W equals 7. So 3W plus 4 equals 7. Subtract 4 from both sides. 3W equals 3. W equals 1. Plug that back into L plus 1 equals 7. So our length is 6. So length 6, width 1. Woohoo, we're having fun now. Okay. There's a 12% brine solution mixed with a 16% brine solution to produce a 15% brine solution. How much 12% brine solution and how much 16 will be used to produce 40 liters? Well, I'm going to call this T for 12 and 16 and call it S. Okay, and I know I've got T plus S equals 40 liters. I don't know how much of each, but I know those. And then I'm going to have 0.12 T plus 0.16 S equals 0.15 times 40. So I need my handy dandy calculator to find that 15% of 40 is 6. So I got 0.12 T plus 0.16 S equals 6. Sorry about that. Had to take that call. Let's go back. All right, so now we have these two equations. And we got to solve or use one of our methods. I really don't need a W there. So I'm going to go ahead and take this one and solve it for S. So we got S equals negative T plus 40. Now I can take that value and substitute it in for S there. So let's do that. I'm going to run out of room here if I'm not careful. So I got 0.12 T plus 0.16 times negative T plus 40 equals 6. Again, still using my handy dandy calculator. So I got 0.12 T plus negative 0.16 T. I'm going to get rid of that plus there. And then plus 16% of 40, or 0.16 times 40 is 6.4 equals 6. And I can combine my two like terms to have a negative 0.04 T. I can subtract 6.4 from both sides. So that equals a negative 0.4. So divide by negative 0.04, divide by negative 0.04, and T equals 10. Take that value, plug it back in up here. 10 plus S equals 30, equals 40. So S equals 30. So I've got 10 liters of 12% brine solution and 30 liters of 16% brine solution. And that one looks really, really tough. Has a lot of decimals and stuff in it, but it's still the same process. Number 16, one customer purchased 2 lattes and 1 hot chocolate for $9. The next customer purchased 2 lattes and 3 hot chocolates for $13. So we got 2L plus 1H equals 9. And then we got 2L plus 3H equals 13. I'm going to take this first one and I'm going to multiply it by a negative 1. And then I'm going to do the addition method, so that's cancels. So negative 2H equals a negative 4. Divide by negative 2, H equals 2. So the hot chocolates are $2. So I got to plug that back in. So I got 2L plus 2 equals 9. So 2L equals 7. L equals 7 halves, or 350. So the lattes are $3.50 and the hot chocolates are $2. Last 4. Going to be doing inequalities, and again, I think I'm going to use my handy dandy calculator here. Let's go 3x plus y is greater than negative 2. And then 6x plus 2y is less than 8. Oh, check that out. That's some really interesting stuff right there. Crosses at negative 2. And this top one crosses at 4. They're both dotted. And then we got, what's that one? 1/3. So 2/3. Really cool. Something like this. And then the double shaded area was between. That was cool. Let's look at number 18. 18 is x plus 3y is greater than 0. And x minus 2y is greater than 4. Yeah, look at that crazy spot where they cross. It's not always nice, easy lattice points. So we got one here, one there, and about right there. And then the double shaded area is over here. Last two, number 19. Bottom one is 4x plus 3y is greater than 9. And then the top one was negative 2x minus 3y is less than or equal to negative 6. Some pretty cool points right there. So we got 2, 0 and 3, 0. That's a solid one. And then this other one is 3. And it's dotted. And my double shaded area is up here. Cool. Last question. We got x minus 3y negative x plus 2y now they're going to intersect. Ooh, way out there. Look at that. X minus 3y is less than 0. Negative x plus 2y. That's going to be going way off the graph. So it's going to look kind of funky. It's going to look like it's not intersecting. But it actually is. But it's way off the graph. So it looks like this on our graph. There's actually a spot out here where it's double shaded. It's a crazy question right there. Let me just double check. I typed it in right. Oh well. All right, so that's your review. That's what you're going to have to do on your test coming up directly. Hope that's helpful. Have a great day.